All right, so I want to start by just talking about fractions in general. When you have a fraction, you basically would say that the numerator is the sum of two parts, right? And the denominator doesn't change. So like if I were going to add something like 3/7 plus 2/7, that would be this, 3 plus 2 over 7, right? Does that make sense? Right? And so I can break that up into two pieces. So if I were to say something like 3/12 plus 4/12, that is 3 plus 4 over 12. But 3/12 reduces, right? And 4/12 reduces. So 1/4 plus 1/3 is the same thing as 3 plus 4 over 12. And so when you start thinking about fractions, you can actually split them up and break them up based on how they would have added together, all right? And so this is what we're doing when we say partial fraction decomposition. Each fraction in the sum is a partial fraction. The sum of the partial fraction makes up the partial fraction decomposition. So what we're going to do is we're going to take these expressions here and we are going to break them down into two smaller ones. It's as if we were to take 5/12 and break it down into 1/4 plus 1/3. Okay? All right, so that's what we're going to do, but we're going to do it with polynomials. All right, so when you do that, just like with the 12, I had to say, well, what makes up 12? Well, 3 and 4 makes up 12. So when you look at these, the very first thing you need to do is you need to look at the denominator and you need to factor it. What makes up the denominator, okay? And so when I look at this denominator, the first thing I need to do is factor it. Factors of 20 that subtract to give me 1. Well, that's 5 and 4. My 5 is negative, my 4 is positive, right? So I know that I would break this guy up into x minus 5, x plus 4. All right? So if I take my original, x plus 13, over the x squared minus the x minus the 20, I know that that's going to be some number over x minus 5 plus some number over x plus 4. Because my common denominator is x minus 5, x plus 4. I just figured that out. Okay? And so just like over here with the 5/12, I know it's some number over 4 plus some number over 3. Because that's my factoring of 12 that I'm using. Okay? And so that's what we're doing here. It's going to be something like that. Now, I need my numerator. So just like up here, 3/7 plus 2/7 is 3 plus 2. So that means that this numerator here should equal this numerator if I get a common denominator over here. Well, how do I get a common denominator? You basically do your cross multiplication method here because we don't really have numbers per se. We have binomials. So I'm going to take the a and multiply it by the x plus 4. So I have a times x plus 4. And I'm going to add to that the b multiplied by the x minus 5. Because to get a common denominator, I need to multiply the a by the x plus 4, and I need to multiply the b by the x minus 5. And now I have a common denominator here of x minus 5, x plus 4. And that equals my x plus 13 over what those are when you FOIL them. We already know that's what they are. When we FOIL them, we actually unfoiled them, okay? So just like up here, I have the 3 plus 2 over 7, and that equals the 3 plus 7 over the 2 plus 7. I know that my numerator, when I add it, should equal this numerator, right? When I added these, I ended up with 5 over 7. So now that I have this with the same denominator and this with the same denominator, my numerator should equal each other, right? So like if I said, well, 3/7 equals, not times, equals x over 7, what do you think 3 equals? 3 equals x, right? Does that make sense? Or if I had 2/5 equals x plus 1/5, well, 2 should equal x plus 1, right? That's common sense. So here, my x plus 13 should equal this guy, right? Everybody agree? So that's what we're going to do. We're going to take the x plus 13, and we're going to set it equal to that piece of it, all right? And so that's what we're going to do. So my first step is going to be to factor my denominator, okay? So factor your denominator.
Yeah, they're ready to get
All right. And then we are going to put a variable. So put some variable like A, B, and C over each factor of the denominator. My third step here is to cross multiply to get that numerator. All right, so we're going to take those numerators and set them equal to each other, okay? Now, we need to simplify this right side. So we're going to distribute, and we're going to congregate kind of our x's together, and we're going to put our ones that don't have x's together. That's what we're going to do here, okay? So I'm going to leave my left side alone, and I'm going to take this and just distribute. That's all I'm doing here. I have a times x plus 4 times a, plus, and I'm going to distribute this guy. B times x minus 5 times b, okay? So far, so good. And then I'm going to group these so that they make more sense. I want to group these x's together, so I'm just going to rearrange it. This is addition and subtraction. As long as I keep whatever's in front with it, it's fine. So I have x plus 13 equals ax plus bx, right? I'm just rearranging it, plus 4a minus 5b, right? So far, so good. Now, if I look at this, I can factor out something, right? What can I factor out? An x. And I have x times a plus b, right? Another way to write that would be a plus b times x, like it's a coefficient. And then over here, I just have these guys. I can't really take anything out, okay? But a and b are both just numbers, right? Remember, they were the numerators? So 4a minus 5b is just going to be a constant. When I finally figure out what a and b are, that's just going to be a constant, okay? And this a plus b, is my coefficient of my x. So I have x plus 13 should equal something times x plus a number, right? Does that make sense? So my x piece of it should equal my x piece of it, yes? So what's my coefficient of my x right here? 1. So I have 1x should equal a plus bx, right? That piece should equal that piece, because that's my piece with an x. My 13, that's my number. Well, my 13 should equal my number. 4a minus 5b. I'm saying they equal each other. So the x pieces should equal, and the number pieces should equal, yes? Does that make sense? So now I basically have two equations here, all right? I've created two equations. All right? So let's look at my two equations. This one with the x, I can actually cancel something out. What can I do? I can divide both sides by x, right? And so if I divide both sides by x, right, I'm going to get that a plus b equals what? 1. Over here, I don't have a variable at all. I just have these, you know, they're kind of variables, but they're all. 4a minus 5b equals 13, right? Does everybody agree I have these two equations? What did you do for bell work when you were given two equations and you were trying to figure out what the numbers that you didn't know? So let's do our Cramer's rule. Our Cramer's rule looks like this. My determinant for my coefficients is 1, 1, 4, -5. So I'm going to say -5 minus 4. That's -9. Let's do x. So dx, well, actually, we'll just say a so we don't get confused. dA, right, is going to be 1, 13, 1, -5. That's -5 minus 13, which is -18. So a is going to be -18 over -9, which is 2. You can solve for b in any way you want, but I have a really simple equation right here. So personally, I am just going to plug it in. I know that a is 2. 2 plus b equals 1. Subtract 2 from both sides, b equals -1.
Why is this problem?
All right, so we know what a is. All right, we know what a is. A is 2. B is -1. My goal was to break my original fraction up into two partial fractions. All right, this is what I said my two partial fractions would look like, right? But I need to know what the numerators are. I just solved for the numerators. So now I just need to put those numerators in. So my a is what? What is my a? 2. So I'm going to say 2 over x minus 5 plus what's my b? -1. -1 over x plus 4. That is my decomposition of that large fraction. So if I were to add those fractions, I would get my question that I started with. If I were to add those fractions, that's what I would get. Okay, my fourth step is to set the numerators equal to each other. Let's see if it'll let me get rid of just that. All right, so this right here, we're going to kind of combine this step. Your fifth step is to simplify the right side. Simplify. So you're going to distribute, and then you're going to group the x's together and the non-x's. That's what we'll call them. Factor your x out. And then here, we're going to set the x equal to the coefficient piece. So we're going to set the x equal to the coefficient piece. And the number equal to the number piece. So that we have two equations, okay? Yeah, 6 is factor out your x, and then your 7 is to set your x equal to the coefficients of your x, and your number equal to the group that represents the number. And so then we have two systems of equations here. So we are going to solve by Cramer's rule. Solve by Cramer's rule. And my last step is to plug it in to my original breakdown of the fractions. All right. Let's walk through it. The factoring of this is x minus 2x plus 1. Everybody agree with that?
Yes.
Right.
So it's a over x minus 2, b over x plus 1. So my numerator is going to equal a times x plus 1 plus b times x minus 2. Okay? When I distribute, I just get ax plus a, bx minus 2b. So that means my coefficient of my x, should equal the coefficients of my x's on the other side. So my 2 should equal the a plus the b, my coefficients, right? A plus b, right? The coefficient of the x should equal the coefficients over here, a plus b. My number then, 5, should equal the ones that don't have an x, a minus 2b. Okay, so my coefficient of my x on this side, the 2, should equal the coefficients over here, a and b, a plus b. My number over here, 5, should equal my numbers over here, a minus 2b. All right, so now I have my systems of equations, and I'm going to set up my Cramer's rule, all right? So it's 1, 1, 1, negative 2, all right? 1 times negative 2 is negative 1, minus 1 is negative 3. So then, for my a, I'm going to plug in the answers, 2 and 5, leave this guy alone. 2 times negative 2 is negative 4, minus 5 is negative 9. I solve by doing negative 9 over negative 3 is 3. So now that I know a, I'm going to just come over here and plug it in. 3 plus what equals 2? Well, negative 1. I subtract 3 from both sides, I get negative 1. So my a is 3, my b is negative 1. So I just plugged it back into this. 3 over x minus 2, negative 1 over x plus 1. All right, so we're going to look at this one together. For this one, the first step is to factor my denominator, okay? So the first step here is, again, to factor my denominator. We've got to factor the denominator, okay? So let's do that. Well, I can take an x out, right? So if I take an x out, I have x squared plus 4x plus 4, right? So I have an x. And then how do I, factors of 4 that add up to 4? Well, that's 2 and 2, right? So I have x plus 2, x plus 2, all right? So in the ones that we just did, we had 2 factors in our denominator. But now we have 3 factors in our denominator. We technically have 2 of your x plus 2's, okay? Does everybody see that? We have 2 of our x plus 2's. So I now need to set up 3 factors, all right? So this original, negative x squared minus 3x minus 8 over this guy, x cubed plus 4x squared plus 4x, is going to equal some number over x, okay? That's my first factor, right? Some number over my x plus 2, that's my second factor, all right? And then I have a c. When you have repeated factors, you use it to every degree. So this was x plus 2 to the first, basically, right? So then this is going to be over x plus 2 squared. Okay. Okay. So I need common denominators here as well. So I look at each piece individually. So instead of doing the cross multiplication, which is kind of easy when you just have 2 fractions, I need to look at each piece. Because the common denominator here is going to be x times x plus 2 squared. Okay? So what am I missing from each piece is really what I need to know. Well, from the a, what is a missing out of this? A is missing the x plus 2 squared, right? That's what I need for that denominator, right? Does that make sense? What is the b missing? Well, b is missing x and one of the x plus 2's, right? What is c missing? Just the x. Okay, everybody see that?
No.
So my common denominator is x plus 2 squared. A is missing the x plus 2 squared, right? It has the x, it doesn't have the x plus 2 squared. B is missing the x and one of the x plus 2's, okay? C is missing just the x from its denominator, okay? So for this one, my numerator is going to equal A, x plus 2 squared, plus B, x plus 2, plus C, x. Right? Does that make sense? And so now I need to just simplify the right side. Okay? Just simplify the right side. Now when I do this, when I simplify, this is FOILed. So this becomes x squared plus 4x plus 4, right? We know this because that's what that was, okay? So I need to distribute an a to all of those. So this is ax squared plus 4ax plus 4a, okay? Distribute the bx. Well, that's going to be bx squared plus 2bx, all right? And then the c doesn't do anything, cx, okay? And that equals this guy. All right, so let's look at each piece individually. Each piece individually, all right? Trust me on this, it's not hard. I'm going to start with the x squared. What's my coefficient on my x squared? -1. So now I'm going to look at everything that has an x squared and pull those coefficients, okay? Ax squared, what's my coefficient? It's a.
My bad.
Bx squared, what's my coefficient? B. All right, so I've taken care of my x squareds, okay? My x's, what's my coefficient on my x? -3. So I'm going to take every x. That's 4a, right? 2b. All right? And c. So far, so good? And now I'm just going to take my constant. What's my constant on the left-hand side? -8. What's my constant on the right-hand side? 4a. I don't even have to do Kramer's here, by the way. What can I solve for? I can solve for a immediately, can't I?
Yeah.
What is a? A is -2. How does that help me?
Did you plug it into the top one?
Plug it into the top one. -1 equals -2 plus b. Add 2 over. What is b?
1.
b is 1. How does that help me?
Plug them all in.
Plug them both in. -3 equals 4 times -2 plus 2 times 1 plus c. 4 and -2 is -8 plus 2, that's -6 added over. What is c?
3.
C is 3. So this one is usually easier because you can usually immediately solve for 1 and then you just plug them in. You don't even have to do Kramer's rule for this one, okay? So my final step is just to go back and plug these guys in up here, okay? So I need to say, well, A is -2, so that's -2 over x, plus B, well, B was 1, that's 1 over x plus 2, plus C, well, C was 3, that's 3 over x plus 2 squared. And that is my decomposition of that one. So if your common denominator is x plus 2 squared, because that's what we factored it to be, you have to do the x, and then because this is to the second power, you have to do it to the first power to the second power. Okay? So my common denominator, that's what I've always known it to be, is this guy. It's whatever it was when you factored. But I have to go back and get a common denominator here so that my numerators equal each other.
Okay.
So I look at this guy. What is he missing to be a common denominator? He has the x. He needs the x plus 2 squared. So I have to multiply the a by the x plus 2 squared.
Okay.
What is he missing? Well, he's missing the x and one of the x plus 2's to have this common denominator. What is c missing? C is only missing the x. And so now my numerators equal my numerators. steps here, we said at beginning, factor your denominator, all right? Then once again, we are gonna set up fractions. All right, with each piece of that factor denominator. And then for repeated factors, you have to use them every time. So to the first, to the second, to the third, however many times it's repeated, you have to use it from that degree up, okay? You are going to simplify the right-hand side using distribution. All right. You're going to set your coefficients of each piece equal to the other side. So my coefficient here was -1. I pulled my coefficients A, B of my x squareds there. All right. And then you're just going to solve. Solve. By whatever method you need to solve. If you already have it like this, solve and start plugging back in. If you need to do Kramer's rule for some reason, then do Kramer's rule. All right. But whatever method you need to solve those systems of equations, we have learned how to solve them.